The overall goal of this procedure is to determine the functional lateralization of language in the brain using a child-friendly procedure. This is accomplished by first applying ultrasound probes to the head to monitor the rate of blood flow in the middle cerebral artery to each brain hemisphere. The second step of the procedure is to monitor blood flow while the participant performs a language task. The third step of the procedure is to extract the average Doppler signal from the left and right hemispheres over a period of interest in which the language task was performed. The final step of the procedure is to examine the difference in left and right activations to extract a laterality index. Positive values indicate left lateralization and negative values indicate right lateralization. Ultimately, results can be obtained that can be used to compare brain lateralization in children at different ages, or for groups with and without developmental disorders.
The main advantage of this technique over existing methods such as functional magnetic resonance imaging is that the participant does not have to keep still, and the method is relatively inexpensive and portable. Demonstrating the procedure will be Georgina Holt and Nick Badcock, a research assistant and postdoc from my lab.
This video will demonstrate the use of functional transcranial Doppler ultrasound, fTCD for short, to assess language lateralization in children. The system consists of a multi-dop with ultrasound probes attached to a headset, a stimulus computer that will be used to show videos to the subject, and a voice recorder for auditory responses. Set up the multi-dop before the participant arrives. Check all connections as described in the accompanying text and product manual. Check that limits are set to ensure appropriate levels of ultrasound are used. Before starting a session, it is important to check whether the child needs to go to the toilet. Seat the child comfortably, as the sessions last between 20 to 30 minutes and gross motor movements can interfere with the Doppler signal. Demonstrate the Doppler headset for the participant using a toy animal. Make sure the child is happy to put on the headset and position it comfortably and firmly. Switch the multi-dop system to pause while preparing the ultrasound probes. Cover each probe with a generous amount of ultrasound gel to maintain the best contact possible between the probe and the skin. While the child watches a DVD, position the gel-covered probes at the temporal window of the skull on each side of the head just forward of the ear, where the bone is thinnest. Start the multi-dop. Adjust the position of the probes to insonate the middle cerebral artery. A satisfactory signal has a characteristic sound and visual pattern. This is an example of a visual pattern from an improperly positioned probe. Note that there is no sound. This is the characteristic low whooshing of the subject's heartbeat from a properly positioned probe. Reduce the power as much as possible, increasing the gain if necessary while maintaining a good signal. Once the signals for both middle cerebral arteries are satisfactory, turn down the auditory output of the multi-dop. Explain the three-step procedure to the child using still pictures.
Okay, and then when we've watched a little bit of video, you're going to see a symbol like this. Do you know what that is?
Question mark.
Yeah, and when you see the question mark, I want you to tell me what happened in the video. So you can tell me as much as you can about what the penguins were doing, what they were playing, what they were eating, anything you like. And then when you finish telling me what's happened in the video, you're going to see a picture of a boy going shh. And when you see that, I want you to be really quiet and still and stop talking and not tell me any more, okay? And just wait a little bit and then the video will come back on.
Start the recording devices and begin the trial. Testing works best if one experimenter is responsible for keeping the child on task and recording what they say.
What happened in that one?
He put his scarf and hat on and went outside.
Very good. And what colour was his hat and scarf?
Red.
Very good, well done.
A second experimenter should monitor the multi-dop to make sure that a suitable signal is maintained. If the signal becomes significantly disrupted, pause the display computer and readjust the probes, applying more gel if necessary. Monitor the child's behaviour and ensure that they are comfortable and relaxed. Here is an example of one trial. The program on the stimulus computer maintains accurate timing of events and sends a marker pulse to the Doppler data file to indicate onset of the language activation period. For this procedure with children, we record 30 trials. We recommend a minimum of 20 trials for accurate lateralization estimation. When the experimental procedure is finished, stop the multi-dop recording and remove the probes. Use tissues to remove excess gel from the participant. Give the child a treat to thank them for taking part. Here is a clean data recording of raw blood flow velocity during one experimental trial. Each visible pulse corresponds to one heartbeat. The event marker indicating stimulus onset is displayed in green. Here you can see data recording for a portion of the experimental session when the signal was poor and intermittently dropped out. These sections are automatically removed from the record by an artifact rejection procedure. This plot shows the averaged signal across epochs for the left channel and the right channel, averaged across all acceptable trials for a group of participants. The language activation period is shaded green. This panel shows the left minus right difference of Doppler velocity. The period of interest for the laterality calculation is also depicted in green. The grey shaded area surrounding the difference velocity represents the standard error of the mean.
When mastered, this technique can be applied in about 30 minutes if done properly.
After its development, this technique paved the way for researchers in developmental neuropsychology to explore cerebral lateralization in preschool children.